There it is. Okay, so this is a parallel circuit, and the reason it's a parallel circuit is that there are currents, different currents flowing in parallel to each other, I guess, right? Okay, so one of the currents, and of course they share the same wire, so but I like to think of them as separate currents. One of the currents flows through this ammeter, through this resistor, through this wire, back to the battery, right? Okay. Another current flows through that ammeter as well. So that ammeter is going to have, it's going to show both currents. It's just going to add them up, right? But this one goes on this branch here, okay, and it goes through this resistor, that ammeter, that resistor, that ammeter, this resistor goes through this ammeter, and then goes back like that, right? And yet another, the third current in this circuit, goes through that ammeter as well. So this one's going to register all three of those currents, right? And then it goes through this ammeter. This will register both of those. But this ammeter here is only going to register this one current there, right? And then through that resistor, through that ammeter, and then back like that, right? So the first step, I think, is to trace out these currents and just see where they go, right? Notice that this current, this ammeter here, is only going to see that current, right? Whereas this one here on the main road is going to see both of those currents. These ammeters here should read the same thing because the same current goes through them, and a current is a current, right? It's not going to change. You don't like have more current here and less there because the resistor uses some of the current or something like that. No. The pressure drops, but the current is current, right? Current is charge, and charge is conserved, right? It's stuff. So that would be, I think, the first step. Let's see what I thought the first step was. Yeah, draw or figure out the currents, right? So the next thing is, I think, to figure out what they are. And we're just going to use Ohm's law for this, and I've picked numbers that work out easily. But the main thing to find the currents is I is V over R, right? So I'm going to go 24. Current is 24 divided by 6. This one's 4 amps, right? And then 24 divided by 4 is 6 amps, is that right? 24 volts divided by 4 ohms, 6 amps, right? And then 24 divided by 8, this one here, this branch here is going to be 3 amps, right? Make these all come out even. Of course, they're not going to in the circuit exercises, but you know, these ones do, right? Okay. And now we can actually answer some of the questions here. Like this one is only registering the 3 amps here. Let's use another color. Okay. This one here is only seeing that one current, so that one's easy. That's 3 amps. Okay. 3 amps is going through this 8 ohm resistor, and so this voltage is, well, V is IR, right? So it's, yeah, we knew that already, didn't we, right? 3 amps times 8 ohms. We didn't figure out anything new here. That's 24 volts. The other way to know that it's 24 volts is that if you look at these wires, I can hook them up, and if I can just move the wires along wire and not through resistors, don't you see that I could have hooked them up right there? Isn't that the same piece of metal? Yeah, there it is, right? Okay. Okay. So it's just connected directly to the battery, and there's no resistors between it and the battery, so therefore if the battery maintains a potential of 24 volts, a pressure of 24 volts, then that's what it reads because it's connected directly to it. It's only when it goes through resistors that it drops, right? Okay, so that's the other way to know. How about that voltmeter right there? What's that one? Where is it connected? It's just connected to the battery, isn't it? Right? So that one's also going to read 24 volts. Right? And then all of these resistors, all of the loads on this circuit see 24 volts, yeah? So in a parallel circuit, there's one voltage and there's many different currents. So this could be the microwave oven draws a lot of current, right? But I don't know, the fluorescent light draws less current, right? Yeah? Does that make sense? Okay, so at your house, Juliana, what's going on here is that as you add these things, as you plug things in, this is how your house is set up. Everything is in parallel, right? And the reason for that is that it wouldn't do, in a series circuit, there's many different voltages, but all the appliances need to have 110 volts or 120 volts or whatever it is, yeah? So it wouldn't do for people to have to do like math to figure out, okay, let's see, I just plugged in a toaster, so now I need to plug in the electric drill. And that would make the voltage just right. No, no, no. Okay? They're all designed to use the same voltage, and so this kind of circuit supplies the same pressure to all the appliances, right? So when you look at the socket there, this side here is maybe the little plug, and that's the big plug or something like that. If you notice, they're like different, or the little slots are different sizes, right? And that's what it is. You're just hooking it up. Everything's in parallel. When you plug it in, you're plugging it in and just in parallel like that, a parallel load. Okay? So the more parallel loads you have, the more current flows. Remember, in a series circuit, the more resistors you have, the less current you get. But here, every time you add a resistor, no matter how big, you're always letting more current flow because you're adding yet another path for current. Does that make sense? Every one of these resistors that you add in parallel is just, even if it's a tiny current, it's more current than was flowing when it wasn't there, right? Okay. Now we can go in and figure out some of the harder ones. This one, don't you see that there's two currents going by? There's the 3 amp and the 6 amp are both going through this one, and this one as well, yeah? Right? So this one's going to be the sum of the 3 amp and the 6 amp. So that's going to be 3 plus 6. This is going to be 9 amps. Right? And then the same two currents here also still add to 9 amps. So it's 3 plus 6, 9 amps. And then this guy here, the current leaving the battery is a whopping, well, it's going to be 4 plus 6 plus 3. Yeah? Because this guy's measuring this current. What is that?
13.
Is it? Yeah, it is. It's 13 amps, right? So 4 plus 6 plus 3, 13 amps on this guy. So all you do, the next step is you just add up the currents, and that's the current that's flowing, right? And of course 13 amps won't blow the circuit breaker, maybe 20 amps does, or they're either like 15 amps or I think if it's 15 amps or 20 amps in your house. So the big main circuits, and then there are bigger ones like for the electric stove or the electric water heater that are many more amps. Yeah. Oh, here we go. That's, I'm just using these currents here. Yeah? A2. Doesn't it have the 6 amp and the 3 amp? Yeah? Are we good? A5, where are we? A5, okay. Yeah, A5 has just the 3 amp going through it, doesn't it? Yeah? Okay, yeah, so V2, this is always, I always like to put a bad, voltmeter there. Is there a single resistor between here and here? Is there a battery between there and there? No, so it's going to read 0. Okay. Now in a real circuit where this wire actually has some resistance, it would read something. It would read something, but this is like a superconductor, and this has infinite resistance. And so no current would ever flow through that. It would read 0 volts because it's just connected to nothing. So this guy's going to read 0 volts. If I move this lead here up to there, then suddenly I'll have something, right? But that doesn't work. Have we answered all the questions? A3, yeah, okay. So what current goes through A3? Just the 6, correct? Because the 3 amp current goes by on the county road and doesn't turn down that driveway, right? So A3 is only going to read this current that goes through it. Yeah?
So how come V2 doesn't have a current, but V1 has all?
V1. Yeah. Well, okay, neither one has current, right? Yeah, but this guy's connected directly to the battery, yeah? Right? This guy's connected to nothing. Or if you trace the wires back, it actually is connected both sides to the same side. And the voltage difference between 0 volts and 0 volts is nothing, right? That's another way to look at it.
Yeah, what if you trace it up?
Well, then you go through this resistor and you change voltage by 6 times 4. Yeah? Yeah? If I trace it this way, right?
Yeah.
Okay, now suddenly I'm tracing through a resistor, right? And so I go up by 24, and then if I go back down